Not again, but I have to read. But thank you so much. The largest fish ever caught had tentacles up to 36 meters long, which is greater than the length of a blue whale. Suppose the jellyfish is located in front of a convex spherical mirror 36 meters away. If the mirror has a focal length of 12 meters, how far from the mirror is the image? What is the image height of the jellyfish? So, this problem is interesting because, well, a jellyfish is so big. Imagine that from the floor to the roof, it's about 3 meters. But that jellyfish is 36 meters long, which is 12 times the distance from the floor to the roof. It's quite big, okay? Like a 12 floor building, okay? Like a 12 floor building height. That's too big. But any case, imagine that for some reason suddenly appears a convex spherical mirror and is located 36 meters away. Okay? Take a look. We need to start writing the data. So let's focus on the data that is provided in the problem. The first data that we have says uh, it's the jellyfish itself, okay? That's the object. The object is going to be the jellyfish. Now, it says that the tentacles are up to 36 meters long, which means that is the height of the object. The jellyfish height is 36 meters, which is greater than the length of a blue whale. Now, it says the jellyfish is located in front of a convex spherical mirror 36 meters away. So, the jellyfish, which is the object, is located 36 meters away from the convex spherical mirror. Okay, so there are plenty of data is being provided. Then it says the focal length of the mirror is 12 meters. It's asking you, how far is the image? Which means that is the distance. How far? I'm talking about a distance. So what is the distance from the mirror? Okay, the image is formed at a what distance from the mirror, and then the question says, what is the image height of the jellyfish? So I'm looking for the image height. So I'm going to transform this data into a list of givens. So let's see what we have here. So we're talking about a jellyfish. It's not too important, but I like to write. I like to write what my object is about because I like to draw it, okay? So we have this jellyfish, okay? And it says that it's 36 meters long. So that means that the object height is 36 meters. The jellyfish, which is the object, is located at 36 meters in front of the convex spherical mirror, okay? So we have the jellyfish that is located at a distance of 36 meters. Yorleni, please turn the camera on. So I know that this is a convex spherical mirror because it is indicated in the problem. It says if the mirror has a focal length of 12 meters, so focal length is also given in this kind of problem and is 12 meters. How far from the mirror is the image? So I want to find the image distance. Remember, the image refers to the reflection, okay? Image distance is unknown. And then It says, what is the image height of the jellyfish? So the image height of the jellyfish refers to this given H apostrophe. H apostrophe is equal to the image height, and I want to know what that is. Is also unknown. So for this kind of problems, we always start by doing the first steps. The first steps are the givens or using the mirror equation. So in the first step, what I'm going to do is I will be using my mirror equation. From the mirror equation, I know that 1 over q is equal to 1 over f minus 1 over q. Now about the focal length, I want to say something. Remember what I said about the focal length of a convex mirror? I told you something about it.
The one side behind is negative.
It doesn't say that it's behind, but the focal length in convex mirror is always behind. Okay? So even if the problem doesn't mention it, you have to put that negative 12 in the focal length to indicate that because it is a convex mirror, the focal length is going to be negative. That's what it means. Convex means negative the focal length. So let's continue with the exercise. So we say 1 over q is going to be equal to the focal, which is 1 over negative 12 minus the that's p not q. That's p not q. Okay? Sorry about it. Minus 1 over p. Amazing. P is 36 meters. So how much do you get from that subtraction?
Negative 9 over, sorry, negative 1 over.
Negative 1 over 9. Thank you, Gerald. Okay. Now it looks like a 9. Okay, take a look. What we do after, we don't forget to apply the reciprocal function. Therefore, we obtain that q is equal to negative 9. That means that the image is going to be formed behind the mirror. Because we're talking about meters, the q is also in meters, okay? Don't forget. Now, after we work with the mirror equation, even if the problem is not asking you to find the magnification, the problem is relating the object's height and the image height, which both are related to the magnification. So in this problem, the second step will be to work with the magnification equation. Okay? Now for magnification, we have two equations. You can say that magnification is equal to negative q divided by p, or you can also say that magnification is equal to h, the object's height, the image height divided by the object's height. Those are the two equations that we can use to get magnification. Now let's see which one can we use. We already obtained q and we already know p. We can use the first equation, okay? But maybe you are thinking, Miss, but I want to use the second equation. Let's see if you can use it. H prime refers to the image height. The image height is unknown in the problem, which means that we cannot use the second equation, though We know about the height of the jellyfish initially, that is the 36 meters. But still, we don't know all the data, so we cannot use the second equation yet. But we can use it after to get the image height. So we're going to be using the two equations. But right now, in this moment, we're going to be using just the main equation. Okay? So this one is going to wait. So let's find the magnification is equal to negative q. The q gave us negative 9 meters divided by p, which is 36 meters. Meters and meters are going to be canceled, and the negative with the negative is going to give you a positive answer. How much did you get from that?
0.25.
0.25. That is okay. 0.25. About the magnification, what can we say? It is positive. What does the positive mean? How is the image going to be? Upright or inverse?
Upright.
Again, the positive, what kind of image means? Real or virtual? Real or virtual image?
Real.
Positive means virtual image. And 0.5, 25, sorry, is less than 1. So the object is going to be reduced or enlarged?
Reduce.
Reduced, okay? Now, we know the magnification, so let's find the image height. So I'm gonna use this equation to isolate for the image height. Image height, so this is going to be the third step, okay? Image height is equal to the magnification times height, object's height, okay? So this is equal to 0.25 times the object height, that is 36 meters. H prime is equal to H prime is equal to
9.
9 is equal to 9. I don't know, but this is not updating. Okay, now it's updating. It's 9 meters, okay? So with this, we already solved the problem. But, you know, Miss Martinez, she's not going to say, just solve the problem. Martinez is going to ask you to draw the ray diagram. Let's be honest. That's the way I am. Okay, so let's do the sketch. So from all this information that we have here, we can work on the sketch. So we start by drawing the main axis, okay, the x-axis. So I'm gonna leave this here. And I will start drawing my x-axis. Let's see if I can work here. It's a little bit complicated for me when I have to use the iPad, but in that case, Okay, so let's see. I will draw my x-axis first. This is my main axis. More or less, okay? And I will draw my convex mirror. Ay, se cayó. Oh my god. Sorry. Bueno, more or less. Okay, now that you have the mirror, okay, now that you have the mirror, we're going to focus on what you have in the problem. Okay, guys, trust me, this exercise is going to be quite big, okay? So, okay, so let's see the units that we have. Okay, let's see what is the information that we need to sketch. We have additional information about the object's height, which is 36 meters, the image height that is 9 meters. We know P that is 36 meters. We know Q that is 9 meters. Actually, it's negative 9 meters. And we know the focal length that is 12 meters. And remember, the focal length is 12 meters. Okay, it's not updating again. Sorry, guys. I don't know why this is not updating. Let's see. So the focal length finally is there with 12 meters. Remember that from the focal length, we can obtain the radius of curvature, which is C. C is calculated with the formula 2 times the focal length. So this is going to be 24 meters. Okay? This is going to be 24 meters. So I'm going to work with this data behind the sketch because trust me, it involves a lot of procedure. Okay. Okay. I think we're good now. It's a big sketch, I know it. So let's see. Let's see the factors. Let's see what factors they have in common, okay? So I'm gonna get that, okay, take a look. 36 is equal to 36 and 9 is equal to 9. So I'm just going to work in this part, okay? So I'm gonna get the factors for each number. For 36, I have the factors 1 is divisible by 2 is divisible by 3 is divisible by 4 is divisible by 6 is divisible by 9 is divisible by 12, by 18, and by 36. Those are the factors for 36. Now, let's get the factors for 9. 9 is divisible by 1, not by 2. It is divisible by 3, not by 4, not by 5. And then it is divisible by 9. 12 meters. Factors for 12, let's see. 12 is divisible by 1, by 2, by 3, by 4, by 6, and by 12. And 24 is divisible by 1, 2, 3, 4, 6, 8, 12, and 24. Now, let's see what is the greatest common factor between all those numbers. We have 1 in
3.
common, but it's not the greatest, okay? 2 is common only in three, okay? Not in all of them. So 2 cannot be the greatest common factor. But 3 is repeated in the 4 numbers, which means that the most accurate scale that we can get is going to be scale 3 against 1, okay? In other words, we're going to divide each number by 3. So this is going to be 36 divided by 3. This is going to be 9 divided by 3, sorry. 12 divided by 3. And 24 divided by 3. So this is 12, this is 3, this is 4, and this is 8. Those are the points that I'm going to put here in my sketch. So my object P is located 12 units in front. So I will start counting 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that point 12 is actually the point where my object, my jellyfish, is going to be. That's my point P, okay? My image is going to be 3 units. Remember, because it's negative, it's going to be 3 units behind the mirror, okay? So this is going to be 1, 2, 3 units behind the mirror. This is my point Q. Now I need to locate my focal. My focal point is 4 units behind. Now this is the point that matters. So this is the focal point. And the other point that we need to put in the sketch is C. C is located 8 units apart. So this is 4, 5, 6, 7, 8. At this point, I will locate my center, my radius of curvature. So this is my other important point. Now, what I know about the jellyfish. The jellyfish, I know it has a height of 36 meters. Remember, we use the scale, we divide by 3, and we obtain 12 units. That means that the measurement, the height of my jellyfish here in this sketch is going to measure only 12 units. So, My jellyfish has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is the height of my jellyfish. 36 meters or 12 units. And I will draw it. I will draw my jellyfish. Okay. Okay, that's my object. Now remember what we do. We start drawing the rays from the top of the object over there. And the first ray comes, remember this, the first ray comes from the top of the object until it touches the mirror. Okay, this is the first ray. Then from the mirror, it goes and it passes through the focal point right there. Remember to make the dash line over there. And then remember that this is extended outward in this direction. So this is my ray 1. Okay, that's my ray 1. My second ray comes from the top of the object, passes through the focal point. Okay, from the top of the object like that. Remember, after the mirror is a dash line. And in this point, where it touches the mirror in this point, I will make another dash line but completely horizontal. Like that. Then the third ray comes from the top of the object until it passes through the point C. Now, where are you going to draw the object? Okay, here it doesn't look very nice, but take a look. The image says that it's going to be located here. Okay, so the point where you have to sketch the jellyfish is going to be this intersection. It doesn't look perfect because I didn't do the mirror perfectly, okay? I just did it with my hand. I didn't measure it. That's why it doesn't look perfect. With the other section, I got it perfectly done. But it's hard to do it like that. Now, in that point, you're going to draw the image, the jellyfish image. So, in that point, we're going to have the reflection of the image. Okay? Now, to see if it really makes sense, what you have to do is compare. According to the data that you obtained, you know that the image height is 9 meters. Remember, by using the scale, divide by 3, it says that the image height should be 3 units. If you compare here the size of the jellyfish, okay, the size of the jellyfish, as you can see, it measures 3 units. 1, 2, 3 units. So with this, we can say that the exercise that we did makes sense. And that's how you sketch it. Now I'm going to show you the other sketch that I did with the other section because that one was better. Take a look. The sketch I did with the other section, I got it perfectly done. The 3 rays. The intersection of the 3 rays right there. The reason why it doesn't seem perfect is because, as I told you, I draw this with my hands. I didn't measure it. But in the end, it results in a really nice quality sketch. Now, the one that I did with you wasn't perfect. Sorry. I wish it was. But anyway, as I told you, follow the idea, the general idea. You know, it says Q is located at 9 meters divided by 3 is just 3 squares or 3 units. So you have to locate your image in the place that it corresponds. Just let me put the numbers here. This is the second ray. And this is the third ray. And that's how it looks like in the end.